Listening to John do the intro, he he covered a lot of what I'm going to talk about, but I'm going to talk about in more detail. And I was thinking that ham radio has been digital forever, starting with Morse code, but kind of late to the networking game, just because the technology wasn't there. We started ham radio networking about 10 years ago using old WRT54G Linksys wireless access points. They worked. They weren't very well suitable. The latest generation works a lot better. So it's really started to take off. If you've ever updated the firmware on your wireless access point at home, it's the same with us. We upload our ham radio firmware into it, and it transforms it into what we call a node. It really took off in 2015 when the coders of this custom firmware figured out how to move the radios in the access points from the Part 15 bands, which are quite crowded, you obviously know that, down into the ham radio bands, which are right next to it. The FCC, in their wisdom, fortunately, saw to make sure that we had frequency allocations right next to those bands, and it's worked out well. Back when Linux was really hot, late 90s, Linksys saw this open source operating system and said, we can base our products on Linux. And they did. The WRT54Gs were one of the first ones. And being open source, the source code was available to anybody that wanted to use it. The open source community looked at their codes and said, we can do better than that. And they spun off a number of different firmwares for the WRT54G. One was DDWRT, which is still going. One's Tomato, and another one's very popular is OpenWRT. Well, being open source, about 10 years ago, the ham said, we could hack on that and make something for our use, and they did. So the ham radio bands are defined by FCC Part 97 regulations, as opposed to the Part 15, which is the unlicensed radio bands. There are 4 bands that we do use for our networking purposes. Once the 900 megahertz band, nowadays it's relatively low frequency. That means it does well through terrain and other obstructions. The downside is it's not ours strictly. Every smart gas meter and water meter in the world uses this band, and as a result, it's quite noisy. Additionally, they only gave us 5 megahertz of allocation there, so it's not real useful. Might be useful for a long haul, low throughput link out in the boonies, but not used very much at all, and I'm not going to talk about it much more. The 2.4 gigahertz band is where everything all started with the Linksys. Those are the 2 different split allocations there that are the ham bands. 3 gigahertz is interesting. In the US, there is no Part 97 allocation on this band. It's all ham radio. That's both good and bad, and we'll talk about that in a little bit. And then there's the 5 gigahertz band. The Linksys WRT54Gs were only 2.4 gigahertz. They never made one available for the 5 gigahertz band, but OpenWRT has been moved up there, so the code we use has been moved up there also once the hardware became available. So anyway, this is the 2 gigahertz band. If you're familiar with wireless, you'll notice that this one only goes up to 6. The Part 15 band actually goes up to channel, 11, 12, 13. But this is the part that we share, Part 97, the hams, with Wi-Fi. And you'll notice the orange part is where unlicensed can't go and where hams can go. In about 2015, they figured out how to move the radios down here. And at that time, doing the beta testing, a 3.5 mile link where I had only about a 75% link quality on channel 1. When both ends moved down to channel -2, the link quality went to 100%. Instead of 25 access points on that channel, there was just me and the other guy. So obviously the signals were quite a bit better and throughput quite a bit better. So here's the other 2 bands we use mostly. Like I mentioned, 3 gigahertz is only Part 97 in the US. That's good, it's all ours. The bad part is they don't make much equipment for it, so it's proportionally more expensive, about double everything else. But it's a very quiet band, and usage of it is expanding. And you can see we share a lot of channels on 5 gigahertz with them, and we have some solely ours. And that's good. There are other ham radio applications sharing these frequencies too, primarily ATV, amateur television. You may not know it, but hams have run SDTV and HDTV repeaters for years and years, and we have to work carefully to coordinate with them to make sure we don't interfere with them. But there are a lot of channels there, and going point to point, they can be reused. So anyway, we've been building this network, expanding this stuff out, but it's just a network. It doesn't do anything. It's all about the things you can get to on the network. On the internet, it would be like Google, Gmail, Facebook, whatever. Without those, it's just a network. So the things you can actually use, and these are the same things you can use on the internet, but using them on ham radio provides us with a lot of possibilities for both our use and emergency communications. You've got keyboard to keyboard, which is instant messaging, voice, video, docs like Google Docs, web servers, whatever you want, store and forward, which is just email. Any email application that runs on the internet will run over the ham radio network. Repeater linking, I'll talk about that in a little bit. Those are ham radio voice repeaters. And you can do pretty much anything you can do on the internet subject to the Part 97 regulations. And there are 2 primary things we have to worry about. One, you can't do business over ham radio. That's pretty obvious. And the other one that's kind of a sticky wicket is technically the ham radio regulations, which were written around World War II when they were concerned about spying, say you can't obscure communications. They were afraid of spies using ham radio. Well, spin forward, that means you can't use HTTPS, you can't use SSH for secure communications, which is pretty much contrary to good network practices. Various ham radio groups, including the American Radio Relay League, are starting to have discussions with the FCC about bringing their regulations into the 21st century. We've been told privately by the FCC that if you have to use secure communications to securely manage your network, it's okay. So that's an ongoing discussion. So anyway, let's talk about keyboard to keyboard. IRC is the grand old daddy of keyboard communications on the internet. You have dedicated channels. You can spin off an ad hoc channel. That can be a one-on-one or one-on-many. It's just text, so it's minimal bandwidth. We always worry on ham radio how much bandwidth you're using up, because it's not like you're 100 megabit down from your cable provider or anything like that. It's much more limited. IRC is easy to use. There's 3 or 4 commands. And the cool thing about it is you can link geographically separate servers together. Here in Southern California, we have about a half dozen servers linked together from Santa Barbara to LA County. And they're getting increasingly used. Oh, let me go back to that. The servers require a bit of technical knowledge to set up and link together, but once they're set up, they just pretty much run. Here's a screenshot of a really busy IRC channel. It's just dialogue going on, and the people who are signed in on the right. This is a very busy channel. I have no idea which one it is. There's an application written specifically for our mesh network. We call it a mesh network. That's a bit of a misnomer. It's just an IP network. It automatically finds other mesh servers on the network, so you don't have to manually connect them. That's a good thing. And it will spin off multiple channels if you want, same as the others. Supports a file upload and download, which is pretty much your Dropbox thing. And it runs nicely on a Raspberry Pi. By the way, the Raspberry Pi is becoming the Swiss Army knife of ham radio, especially ham radio networking. Pretty much every application I'm going to show you here is hosted very nicely on a Raspberry Pi. And at 35 bucks, we're putting one on every mountaintop we can get to. Anyway, here's a screenshot of MeshChat. It is a web interface only. IRC can run either a dedicated client or there are web interfaces for it. This is written by Trevor, K7FPV, and this was his demo screen. So it's pretty easy to use. Just type and hit enter. Voice over IP. This photo is about 4 years old before we were, when we were working on testing VoIP. On the left, you see an old Cisco phone. That can be had for about $25 on eBay. On the right is a Grandstream VoIP PBX. There are many, many implementations of VoIP PBXs on Linux, and they will run nicely on a Raspberry Pi. Asterisk is the most popular one. At the time, the ham who was setting up this network was not Linux literate, so he wasn't comfortable on deploying one of those. So he bought a commercial Grandstream, and it's worked out well. So spin forward to a couple of months ago, I took this photo. The Cisco phone's been replaced by a Grandstream. You can see I have one missed call, and the red light indicates I do have voicemail waiting. That Grandstream PBX is now sitting in a radio building, a shack, on top of a mountain in central Ventura County. And we have a dozen and a half users, and usage is increasingly growing. It's amazing how frequently we use this. It's pretty cool. So you don't have to dial to talk to somebody over voice over a network. You can use voice chat. Things like Team Talk, TeamSpeak, Mumble, they're all the kind of applications you see gamers use when they coordinate their teams over the internet. We chose Team Talk because it happens to be non-encrypted, and that's just one less thing to have to deal with. So these will let you do one-on-one chats, many-to-many, a chat room. You can set up as many channels as necessary. And unlike a ham radio repeater where you talk, say, over, and then the other person talks, this is digital data. It can be interwoven, just like the internet sends multiple packets out from every network thing in your house. The computers, the phones, the smart TVs, they all use the same internet connection simultaneously. And Team Talk does the same thing. It takes advantage of that. Ham radio communications are generally defined as a communications grade channel. That would be audio frequencies 300 to 3000 hertz. It's highly intelligible, but it's not high fidelity. It wasn't intended to be. These VoIP applications will take advantage of the bandwidth they have, and they will set the audio quality as high as they can. When you're on a headset talking to somebody on the other end and it's a good quality link, it's like they're in the same room. It's a pleasure to listen to. Much easier on these old ears, I'm afraid. And there's 3 modes. I had to spell out the acronyms because I realized we probably have a lot of non-hams here. PTT, push to talk. I use the left Alt key to transmit. During our weekly voice nets using Team Talk, I put the headset on and turn it to Vox, and I can lean back, put my feet up, and when I want to talk, I just start talking and it goes into transmit. And the neat thing about this, compared to a ham radio repeater, you can't interrupt a person on the other end when they're talking. It's one-way transmissions. With this, it's very natural. You can be rude and interrupt anybody that's talking. Alternatively, you can just leave the microphone open and it transmits all the time. It only uses about 30 kilobits per conversation, 30 kilobits per second, so it's not a burden on the network. Where you might use this is some sort of incident where we're providing communications and you put a couple laptops with open microphones on Team Talk into the same channel, and people, say in an emergency room or an EMS or an EOC at a PD can walk in and just start talking to the other person on the other end. You know, hey, is Nurse Jones there? And somebody says, hang on a second, I'll get her. We haven't used it yet, but there's a lot of possibilities there. These servers, in addition to using voice, a lot of them will let you share video, share files, and desktops. And TeamTalk does that. So here's a screenshot of a weekly net we had last December. And you can tell that by the Christmas trees. There were 4 of us running video. On the left, you can see the participants. The one highlighted in green is one who's talking at the moment. These are 4, I think 800 by 600 screens. Total occupied bandwidth is about a megabit per second. This server was hosted on a Raspberry Pi, and watching it loaded down like this, which is about as heavy as we ever loaded, is 2 or 3% CPU utilization, so it was loafing. This, if you look at the top, you can see there's a chat tab, 4 video sessions going, and 1 desktop tab. One of the hams on the left, Joe K6NE, had just given us a slideshow over TeamTalk of the photos of his ham radio repeater site on a hilltop in Ventura after the Thomas fire came through and ravaged everything, and it was pretty grim. But it shows the utility of something like this, either just having fun or rolling it out in an emergency situation. Hams are frequently provided to called on to provide emergency communications, and we're exploring what all we can provide to the agencies via this digital network. So we're trying all sorts of different things. So webcams. Webcams are no big deal, but this one was 40 miles away, network miles. This was, the guy in the foreground is Ben, AI6YR, also a tech specialist. Lives in Newbury Park, California, which is here in Ventura County, about 15 miles to the west. Every year, ham radio clubs participate in an event for emergency communications preparedness. It's called Field Day. Your club goes out, operates in the boonies, where it might be in a shopping center, but the point is you operate not on electrical power. You get set up and you operate and see who you can communicate with. It's partly emergency preparedness, and to be honest, it's partly a social event and partially a contest. But back in 2016, on the Friday night they were setting up, Ben put a video camera on the mesh network, and I captured this screenshot of them setting up. They're only 6 or 7 miles away, but there's two ranges of hills in between, so we had to go around the horn and 3 hops and 40 miles, so it was pretty cool. This is an open source application called iSpy. If you have multiple cameras you want to watch, internet, at home, ham radio, whatever, highly recommended. It's a very, very good application. This was a screenshot a year ago. Upper left, for some reason, Glenn decided he wanted to have a tower cam, so he's got a tower cam. The one on the right is my driveway. Not that that's interesting, but it was the first camera I ever set up, and it was a test setup, and I just left it there. The bottom 2 are 2 hilltop cameras here in Simi Valley, California. They're on the mesh network. They're about 8 miles apart. The one on the lower left is on the western end of the city looking north. Excuse me. The one on the lower right is on the southeastern corner of Ventura County on a mountain looking west-northwest. And if you look carefully, you can see the smoke from the Thomas fire that went on December 4th, and at the time was the largest brush fire in Ventura County history, California history actually, and it's just recently been surpassed. But it just absolutely ripped through the town of Ventura. I'm going to talk a little bit more about that in a second. So this iSpy, every morning that I come into the ham shack, I fire this up just to make sure all the cameras are working. I don't leave it up full time because it occupies bandwidth. I just leave it up for a few minutes, make sure it's okay, and do it. And it's on a large screen, second screen off to my right. And I did that one morning, and I saw a flicker in one of the cameras, and I looked over and it was gone. I thought that was weird. So I set up to do a screenshot. And it happened again, and I stabbed and got a screenshot, stabbed a key and got a screenshot. This is what I got. We're still debating as to whether that's a raptor or a rodent. That's a tubular camera, and the lens is about a foot out from the tower. So whatever it was, it had to do quite a little bit of gymnastics to peek in the lens there. That was pretty funny. This next one is not nearly so funny. The Thomas Fire broke out in Santa Paula, California. It's north and west of here in hilly country. Hot, dry, windy weather. About 6 weeks prior to the fire breaking out, Ben, the other tech specialist I mentioned, had dropped me an email and referenced an article that talked about how to stream webcams out to YouTube. And he said, maybe see if you can figure this out. Maybe we can use it someday. Well, that was late September. Early December, he pinged me and said, hey, fire in Santa Paula. You got a webcam up there? Well, as it so happens, we had a inexpensive tube cam up on top of Sulphur Mountain, south of Ojai, California. And it happened to be pointing east at where the fire started. Oh, it was a different camera, different server, different site, but it took me about 45 minutes from the time he pinged me to get it rolling. So we got about 2 hours of the fire approaching before we lost electrical power at an intermediate site. It was pretty scary. Interestingly enough, 3 or 4 days later, I got an email from a fire inspector from the Ventura County Fire Department asking for that URL. We learned later that was the first video they ever had of the fire, and they found it useful. Since then, we've decided and realized that ham radio installations are frequently on mountaintops where there is no commercial nor governmental presence, so we may have a unique viewpoint of the surrounding area. So we're pushing out the mesh network to all the hilltops that don't already have it, replacing the cheap tube cameras with pan tilt zoom cameras and getting set up to stream them to YouTube if need be. And in fact, we did it for a small brush fire here recently. So it kind of drove home the utility of this digital network. Editable docs. You've probably all used Google Docs, no big deal. You may or may not know that you can edit a document concurrently with somebody you're sharing it with. Excuse me. It's kind of spooky. You're working on a spreadsheet and all of a sudden there's a new column and all of a sudden these two rows are bolded. But it's very useful for collaboration. Etherpad is a lower end open source application like that. Does do concurrent editing. Currently it does text and tables only, no spreadsheets, but it's very useful. And you can see here's a sample of somebody who was using it. The colors correspond to the people. So it could be very useful. We tried it, it works fine. We're not currently using it, but it's in our toolkit if we need to deploy it. Email. SendMail is the common email protocol. Anything that speaks SendMail can transfer email. For ham radio, we have a suite of applications shown there, RMS Express, Outpost, and WinLink, that were developed for transferring mail between ham radio stations via ham radio. WinLink is used predominantly on HF, where you transfer a message, several hundred miles, maybe up to the state government if there's an emergency, something like that. For local communications, we have, 3 or 4 or 5 of them in the county, and they use 220 megahertz packet radio for transferring, and that's 1200 baud. They move messages and limited size attachments around that way. As a test, we swung a couple of them over onto the mesh network, and the comment from the operators was, wow, does that move traffic fast? So lots of potential there. You remember back in the old dial-up days, there were BBSs. You could chat rooms, store and forward email, share files, stuff like that. And most of it was DOS-based. It was pretty ugly. Well, spin forward to the 21st century, there still are BBSs. Now they have a web GUI. And we found this Citadel BBS. Runs fine on a Raspberry Pi. You've got all the things you would expect, chat rooms, libraries, a calendar. If you had a group of ham radio operators that communicated a lot and they found this to their liking, you could deploy this for them. Ham radio repeaters, let me dial back. We use the UHF and VHF bands a lot. That's 300 to 3,000 megahertz is both of those bands. I'm saying that right? Yeah, the VHF band is below 30 to 300, and the UHF is 300 to 3,000. Well, on those frequencies, communications tend to be line of sight. There's no ionospheric bending or anything. So if you want to talk to a ham that's farther away than a couple of miles, you need to go through a mountaintop relay site called a repeater. And it's typically FM, and it works fine. If you want to go farther than that repeater's coverage, you link two mountaintop repeaters together. And typically, that's done with a couple of other repeaters that are put on a specialized linking channel so they don't interfere. Well, that's quite a bit of expense. You've got the big expensive cavities, big antennas, more power, stuff like that. Well, it turns out that these companies make these repeater linking hardware, and all they want in between is Ethernet. They'll provide all the necessary analog and digital signals in and out and transfer them over an Ethernet connection. Typically, that's the internet, but it can be the mesh network, and people are starting to deploy these because if there's already a mesh network between two mountaintops, it's very easy to hook the repeaters together into a repeater linking system. Something else you can roll out is put your weather station on the internet or on the ham radio network. This application is called VWX, and I can't say enough about it. It's open source, runs on pretty much any operating system, supports a vast array of weather stations. This is mine here. The nice thing about VWX is, in addition to having a nice web interface that you can look at, it will send stuff up to Weather Underground for you, so you can have your weather station on there. It will FTP stuff up if you have a site. It will SCP, so Secure Communications Protocol, and there's 3 or 4 other ways of it moving your data up where people can view it. So this one's out on my mesh network. It's also out on Wonderground. Recommended. So those are the applications that we've played with and tested. There's lots of other ones out there. Some people use IRC for keyboard to keyboard. Some people use mesh chat. There's a big VoIP phone network on the East Coast. We're just rolling it out and limited here. But what about the equipment? What do you use? About 5 years ago, the people developing the mesh networking code for ham radio discovered that they could port it from Linksys to the Ubiquity access points. That was because OpenWRT had done the initial port, and we just build on top of theirs. And those radios are available for the four amateur bands we talked about. And they're outdoor access points. You don't have to worry about weatherproofing them. Much easier. You don't have to hack a weatherproof enclosure and worry about running coaxial cable to external antennas and blah, blah, blah. Much less hassle. The old Linksys ran 60 milliwatts of power. All the Ubiquities run 600 milliwatts, 10 times more, 10 dBm more. And most of the models have built-in directional gain antennas, which is one less thing to hassle about. You put it up, point it where you want to go, and you're done. And The Linksys stuff now is, I don't know, pushing 20 years old. Really, really old technology, relatively speaking. These have modern, faster processors, more cores, more RAM, more ROM, and the radios in them. I just can't say too much about the technology in the radios. They're transceivers, you know, they transmit and receive digital data, multiple protocols at the same time, just amazing. And the Ubiquities have 2 of these radios in them, unlike the Ubiquity that has 1. And why is that? Because they can run what they call MIMO, multiple input, multiple output. The protocol they transmit is 802.11n. What that does is, for a given signal strength from point to point, you could transmit one data stream horizontally polarized and another one vertically polarized, and the receiving end will mash them together and give you double the throughput for the same signal strength. Very, very nice. By the way, if you ever want your head to hurt, go read the 802.11 description on Wikipedia. I've gone through it 3 times and my head still hurts. Power over Ethernet is the way to run power over an Ethernet cable. The Linksys did not have that. Pretty much every outside access point, anything you put outside anymore, wired, will have a PoE option on it. Simplifies things, simplifies cabling substantially. These are low power, 600 milliwatts with a gain antenna, and they are line of sight, so you have to treat them like a, well, we call them handy talkies, you'd call them walkie talkies. The low power, line of sight. So if you want to talk to anybody farther away, you go through a hilltop relay. For an FM ham radio, it's an FM repeater, voice repeater. For the digital network, it's what we call a node. It receives it and retransmits it. And we'll talk about that a little bit more. So here's what you do. These are Ubiquity nanostations, the M2 and the M5. They look identical. Inside that little plastic box, which is maybe 10 inches tall, is the CPU, the RAM, the ROM, the Ethernet interface, 2 radios, and 2 beam antennas, one vertically polarized and one horizontally polarized. And you get all of that for less than $100. It's amazing. You tie wrap it to a mast up high where you've got line of sight, and you're good to go. The nanostations are good out to 5, 6, 7, 8, maybe 10 miles. You get out much farther than that, you need more gain. This is a Ubiquity power beam. It looks big, but I think it's about 10 to 12 inches across, depending on which model you get. You can really reach out and touch someone from, 15, 20 miles away with that. Those are good for on top of a roof, but for the high-level access points, you need a little more flexibility in your antennas. So what Ubiquity has done is repackage those radios in what they call a rocket. You can see the 2 little SMA coaxial connections on the top. That lets you hook up whatever antenna you want. So on the left here, if you can see the Ubiquity rocket clipped on the back of an antenna that looks like a very, very large bread loaf. Those are called sector antennas. And they're called that because they're designed to cover a sector of the compass. You can get them in 45 degree, 60 degree, 90, 120, and even 180 degrees. If you've ever seen a cell phone site, you've seen a number of these all the way around the tower. That's so they can give circular coverage. And again, they're MIMO. They have directional gain antennas, both vertically and horizontally polarized. On the right are omni antennas. They radiate 360 degrees. Again, they have vertically polarized gain omni antennas and horizontally polarized gain antennas, and they're quite pricey. They don't get used as much as you'd think because very typically when you put something on a mountaintop, you want to direct the energy down into the valley or that valley in 180 degrees. So typically they'll use 2 nodes with 2 sector antennas pointing different directions, but they are available. So what else do you need to put this radio station, digital radio station up? If you've ever left a piece of plain old Ethernet cable out in the sun for a year, you'll discover that the outer jacket crumbles into dust. the UV just does a number on it. So you need something called outdoor network cable. Direct burial cable is what it's called also. Ubiquiti recommends shielded cable. And if you live in Florida or other lightning-prone areas, I'd certainly recommend it. Plus, all of the hilltops use shielded. Here in California, where we hear one peal of thunder every couple of years, maybe, I don't bother. I've had 4 radios up for 4 years and not had an issue. Your mileage may vary. The mesh network is a dedicated network. It runs on 10.0.0.0. And unless you make special provisions, there's no internet access. So it needs a dedicated computer. But it can be any old laptop or something. If you're running more than one node or you put a Raspberry Pi on your mesh network, you'll need a little network switch for it, but they're not expensive. And very, very important, I mentioned this before, you need a clear line of sight because microwaves and trees don't do well. If you don't pretty much have a clear shot to the far end, you'll have to jump through hoops or find somebody halfway in between to relay for you. So, back in the old days, 4 years ago, when we were operating in the Part 15 channels, it was a struggle to get any mileage at all. This is a photo of a ham station about 3.5 miles west of here. You can see the little nanostation M2 at the top of a 50-foot tower. Even with that and a 18 dBi sector gain antenna at my house up at 50 feet, our link qualities were only about 75%. Spin forward to today, running on channel -2 on the 2.4 gigahertz band, we have 100% link quality both directions, and his nanostation, that mast is now 30 feet tall. No need to go any higher. This is another ham here in town. He's got line of sight, and he's got a mast up there with some VHF and UHF antennas on it. Looks like he might have a wire Yagi too or something, but if you look carefully, about 6 feet off of the peak of the roof, he's got a nanostation there pointing at the nearest hilltop. That's all he needs. And if you have really good line of sight, you can just hang them on the eaves of your condo. This ham is on the west end of town, and he's got 2 nodes looking up at an adjacent site. One's a nanostation M2 on 2 gigahertz. The other's a nanostation M5 on 5 gigahertz. And why would you want that? Well, there's a 2 gigahertz and a 5 gigahertz node up on that hilltop, so he has 2 links. His data goes on the best link, and if that fails, it fails over. So this gives you some redundancy. This is where we're putting it at every EOC and every hospital that we're putting mesh in, so they have redundancy, and we make sure they can talk to 2 different sites or 2 different nodes on the same site, depending on the topography. We also do remotes. This was a remote site at one of the aid stations on a benefit bicycle run the local Red Cross did a couple months ago. Ride for the Red, I guess. I think that's what they call it. If you look carefully, you can see the tube camera on top of the SUV parked there. That's aimed at the aid station. There's an air grid up at the top of the tower pointing at the nearest node. What we did was we streamed video from 2 of their sites. Excuse me. I captured data from both of them simultaneously and streamed it out to YouTube, and the Red Cross chapter that was sponsoring the race switched alternately back and forth between the YouTube channels. Worked very well. We're going to expand our use of that, and this would be very handy in an emergency. If you didn't have a mountaintop camera on a fire or a flood or something, you could put a portable site out there, and they will run off 12 volts. Which is handy. Okay, let's look at mountaintop sites. This is the small class. This is in North Orange County. Looking south, there's 3 nodes here. Back behind the camera, back behind your view here, are some solar arrays and batteries. He has a pan-tilt zoom camera up at the top and a fixed tube camera down at the bottom. He doesn't have a weather station here, but the tube camera is focused on a clock-type thermometer he has strapped next to the solar panels. So here's a medium-sized site. This is in the Camarillo Hills in central Ventura County. This little site, which is just a shed, is solar powered with augmented with AC. There's a UHF and VHF voice repeater here linked to the county network. And you can see the two dishes there relaying the microwave network in and out. And those are on ham bands. The user access point, excuse me, is on the left. It's the Omni, the white tube you see there, and it does quite a good job of covering the area. This is your medium-sized site. This is in the large category, definitely. This is a commercial tower on Pleasants Peak in North Orange County, California. All of this stuff in yellow is ham radio mesh networking stuff that's been added to the tower over the last 4 years. So you can see there's quite extensive coverage. A couple of the mesh developers live in Orange County, so they have a head start on a lot of the rest of the country. We have some mapping software that a local ham wrote. It goes out and talks to the nodes, queries them about what they can talk to, where they are, signal strengths, etc., and he puts them on a map. Because he has latitude and longitude of all the nodes, you can click on each one of those little node icons and pull up a pop-up that tells you bearing and distance to the nodes it's talking to and the signal strength. So it's really handy. And he has all of that's kept in a database, and he lets me export a CSV file out of it, and it's really handy for sorting and selecting and so who's behind in their code and who has the best signal strengths and who has the worst. This doesn't go all the way down to the Mexican border, but recently we bridged a gap north of downtown LA and spanned the northern and southern sections. And from the very northern point you can see there, San Ynez Peak, down to the Mexican border is about 260 airline miles. Actual hop miles is about 280. So we're making good progress. So the group that develops the software is the Amateur Radio Emergency Data Network. It's a small group of dedicated hams who also write code, for which we're very grateful. It's at ardenmesh.org, and there you can get the software downloads, the how-tos, excuse me, FAQs, all the documentation, and some very good forums. So to do all of this, you do need a ham radio license because they're in Part 97. Unlike the Part 15 stuff, which the FCC has designated unlicensed, you do need a ham license. So what's required? All you need is the technician class license. It's the entry-level license. And no, you don't need to learn Morse code. They dropped that requirement for all the license classes maybe 20 years ago. There's instructions on getting the license at arrl.org. Very helpful there. The test itself is only 35 questions. And the ARRL very helpfully has question pools. And there are example tests all over the internet. The FCC probably has them too. There might be an app for that as far as I know. Wouldn't surprise me. Used to be, back in the day, you had to drive to the FCC office and take your test. That was grim. Well, quite a few years ago, the FCC allowed certified volunteer hams to do the ham tests. They're called volunteer examiners, and many ham clubs periodically give the ham tests, and they will send the data into the FCC, and you get your license a couple weeks later. And as soon as it appears on the FCC on the internet and their website, you're good to go. That tells you how to find an exam session up on the ARRL website, or contact your ham radio club. By the way, there is a list of ham radio clubs up there, a finder. The VEs are allowed to charge what's required to duplicate exam materials and stuff like that. The tech license has been expanded over the years. It does have voice privileges on VHF and UHF, so you can buy a handy talkie and talk to your local new ham friends, and also does have limited ham radio privileges. I meant to say limited HF privileges. The HF bands are the ones that are long haul around the world, use the ionosphere for bouncing signals all over the world. And they don't have to be voice either. We have digital modes on HF. So, do we have any questions? John?
At this point, if you do have questions for Orv, you can use the chat box at the bottom. Also, the people who joined late, if you haven't signed into the chat box with your name that you registered with Eventbrite, we would like to be able to communicate follow-up material, and we need to know your real name, not your Zoom name.
So this computer I'm giving the presentation on not only has internet access, but it has mesh access, a mesh network access. The shot I'm showing here is from that site I talked about at the west site, west end of CME. This is running on a Raspberry Pi. It takes a screenshot from the camera every 5 minutes. Additionally, I have some telemetry up there, some USB temperature probes. The Raspberry Pi has what they call a hat, a plug-in card that lets me measure battery voltages, and I measure the voltage out of a wall wart that's plugged into the wall, and if the AC voltage goes away, the DC voltage goes away, and we get an AC power fail. So anyway, that's the west end of town. This is the central part of town. I can actually, let me see if I can do a live feed here. This worked the other day, right, John?
Yes.
Yeah, there we go. I could do a pan-tilt zoom on this one. It's was upgraded a few months ago. You can see the CME 118 freeway running through town in the distance. That's no big deal, but from this camera, it goes to the node, goes west to the western end of town, back east to a mountaintop on the eastern end of town, and then back down to my location in the middle of town. And this is pulling about 500 kilobits per second, so it works very well. Let me see here if Paul's home. See if we can hear this. Can you hear the ringing, John?
I don't.
Oh, never mind.
Yeah, we had to do that special checkbox to hear your computer's sounds.
Oh, he's going to call me back now. Which computer checkbox would that be? Oh, never mind.
It was on the sharing.
Yeah. Should I do that?
No, because we'd have to go all the way out and back in, and I think
well,
we're
time's about up.
Yeah, you filled it real well. I'm curious to know whether you climbed up that big giant tower to add any of that equipment to the nodes and stuff.
No. Oh, there was a question about a Raspberry Pi. A Raspberry Pi is a tiny little computer about this, little bit larger. I don't know, it's 3x5, $35. You can plug keyboard, mouse, network, low-end computer, graphical user interface if you want. Doesn't run Windows, runs some variations of Linux, and there's a very simple version of Linux you can start on. A lot of computer classes use those for training, for software and hardware training, and they're just awfully useful. It's just really useful. If you really want to play with a computer, a Raspberry Pi is a good place to get started.
Absolutely. Our computer club has a small group that all went out and bought Pis, and they're trying to, learn to use them, and it's amazing. It's a Raspberry Pi with just a Pi, and it's a little bit larger than a credit card. So neat. Well, I would like to definitely thank Orv for sharing with us this afternoon. It's been wonderful. If you do have a question, the chat box will remain open after we quit this live part. Orv, did you have the screen with your contact information?
Oh,
just
I can pull that back up.
Back up just for a second. So
pull that back up real quick. You see that, John?
Yes, yes.
I'm happy to answer any and all questions.